Today's lesson is on differences of squares. A difference of squares looks like a squared minus b squared. So you have one number that is squared, and subtracted from it is another number or another term that is squared. And that factors into a plus b, a minus b. You might remember that we did this earlier in this chapter, and we called it the product of a sum and a difference. So a plus b is a sum, a minus b is a difference, and when you multiply them, that is FOIL them, you'll remember that our first and our last remained, but our inner and our outer canceled each other out. So here's the formula you need to memorize. A squared minus b squared equals a plus b times a minus b. And it's going to be a lot easier to memorize, to factor something that looks like this if you've memorized this formula. Let's take a look at a couple examples. Number one, factor this completely. 16x squared minus 9y squared. Notice that 16x squared is a perfect square. It factors into 4x and 4x. A perfect square is something times itself. In this case, 4x times 4x is 16x. There is a subtraction in the middle, and 9y squared factors into 3y and 3y, because 3 times 3 is 9, y times y is y squared. So using the formula, a would be equal to 4x, b would be equal to 3y, and then a squared minus b squared equals a plus b times a minus b. So my final answer is going to be 4x plus 3y, because 4x is a, 3y is b, times 4x minus 3y. So the same terms in the same positions, one's a plus, one's a minus. And that's your final answer. Here's one, but what I'm noticing in this problem, 3x cubed minus 27x, is there's actually a greatest common factor that I can take out of both of those. My greatest common factor is going to be a 3, because both 3 and 27 are divisible by 3, and an x. Each of them has an x. And when I factor that out, I'm left with x squared minus 9. And x squared minus 9 is a difference of squares, because what we have here is a is equal to x, because a squared would be x squared, and b is equal to 3, because 3 times 3 is 9. So my final answer would be 3x times x plus 3 and an x minus 3. And again, for any of these, you can check by foiling x plus 3, x minus 3, and then distributing a 3x, and you should get back to where you started. Here's one that's a little more complicated. I have x to the 4th minus 16. Now notice that x to the 4th is actually a perfect square, because it's x squared times x squared. Remember, you add the exponents, and 16 of course is 4 times 4. So that's going to mean, using my formula, a is equal to x squared and b is equal to 4. So plugging that into the formula, it's going to be a plus b, a minus b. It's going to be x squared plus 4, x squared minus 4. But notice that x squared minus 4 is also a difference of squares. X squared is x and x. 4 is a perfect square, it's a 2 and a 2. So x squared minus 4 is going to factor into an x plus 2, x minus 2, and don't forget we had an x plus 4 here, and that's actually prime. That cannot be factored. So my final answer is x squared plus 4 times x plus 2 times x minus 2. And actually, for these three factors, the order doesn't matter. You could put them in any order. Doesn't matter if the x squared comes first. I'm sorry, the x minus 2 or the x plus 2 comes first. Number 4. 6x cubed plus 30x squared minus 24x minus 120. Looking at that, what I see is that there's a greatest common factor of 6. So I think I'll take that out first. Whoops. Now, looking at the stuff that's left in the parentheses, I notice that I have 4 terms. And remembering what we do when we have a polynomial that has 4 terms, quite often that can be factored by grouping. So I think I'll just add the pink parentheses inside here. I group my first 2 terms. I group my second 2 terms. And out of the first set of pink parentheses, I'll take out my greatest common factor, which I think is going to be an x squared. And that's going to leave me an x plus 5. Out of my second set of pink parentheses, I'm going to take out a negative 4. And that's going to leave me an x plus 5. And remember that when we have the repeated factor here, that becomes part of my answer. We'll keep just one of those. And then you put these 2 terms out front together, x squared minus 4. And then let's not forget to bring down that 6. That needs to come down here too, because we factored that out originally. But I don't think I'm quite done, because what I'm noticing right here is an x squared minus 4, which is another difference of squares. I think we had one of those in the previous problem. That's right, x squared minus 4 factors into an x plus 2, x minus 2. So my final answer is going to be 6 times x plus 5 times x plus 2 times x minus 2. And again, any of those binomials can go in any order in your final answer. The thing you really need to remember here is don't forget about this 6. That needs to come down and be in your final answer. Okay. And our last example is using the zero product property to solve an equation. Let's take a look at this. X squared minus 4 over 25 equals 0. First thing I want to do is factor the left-hand side of the equal sign. X squared is an x and an x. And 4 over 25 is a perfect square. Don't be freaked out by the fact that it's a fraction. 4 is a perfect square. 25 is a perfect square. So this will factor into 2/5 and 2/5. Think about it. 2/5 times 2/5. Multiply across the top, multiply across the bottom is going to give me 4 over 25. So this will factor into x plus 2/5, x minus 2/5, and that equals 0. Using the zero product property, each of those is equal to 0. X plus 2/5 equals 0. X minus 2/5 equals 0. And subtracting 2/5 from each side, x equals a negative 2/5. And adding 2/5 to each side, x equals a positive 2/5. And since notice we have the same number, the same answer, but one is positive and one is negative, a cool way to write your answer is to say x equals plus or minus 2/5. And that actually means x can be a positive 2/5 or x can be a negative 2/5.